Hello, everyone. I'm Jim Garrison. I want to welcome you to this session of Humanity Rising. As we begin today, I want to address a comment that was in the chat yesterday about this relationship between the coherence that we seek on Humanity Rising and the chaos in the external world. And there was a question about why we start with the news and we draw attention to the chaos, and wouldn't it maybe be better just to leave that aside and just concentrate on the opportunities in the crisis and the possibilities for a human renewal? I've been thinking about that. It was a very good point. I think it was made by Kurt Kruger, if I recall correctly. And I've been pondering that. And I want to open today with a reflection. And I was drawn in my thinking to the work of Ilya Prigogine, the Nobel winner in chemistry back in 1977, for the work that he did in chaos theory. He was one of the pioneers of chaos theory, what he called dissipative structures. And what he realized through his research is that there's an inherent connection between coherence and chaos. And that, in fact, if you look at any kind of chaos, embedded in the deeper layers of the chaos is a coherence that no matter how dissociative or disconnected reality appears to be in our experience, it is emanating out of a coherence that we can't see. But if somehow we can align with the underlying coherence, can actually enable the chaos to upgrade to a higher level of coherence, that there's actually an integral relationship between coherence and chaos, and that in fact, the coherence that we seek emanates out of the chaos itself. And that's why when we talk about crisis and opportunity, there's really no opportunity if there's no crisis. So what we seek to do at Humanity Rising is to highlight both in a dialectical and I would say creative tension that enables us to understand the chaos more deeply, but with an awareness of the interconnectivity between the chaos and the coherence. So, for example, when we heard from the gentleman in Israel, a very senior member of the foreign policy establishment, who's been the director general of the foreign ministry there in Israel, and an ambassador to South Africa, and actively involved in the politics of Israel, when he was talking to us about the rise of Jewish supremacy and the relationship between the rise of Jewish supremacy and authoritarianism that is eroding democracy in Israel and giving rise to those extraordinary protests that we saw even yesterday. That was an important description of the chaos, and it was important because in the United States, we have the same thing. The rise of white supremacy, the rise of racism, the rise of authoritarianism, and an ongoing coup attempt to subvert democratic processes and the capacity of all the people to vote. So by understanding what's going on in Israel, by understanding what's going on in the United States, and we could add the Great Britain and in France and in other countries of the world that have been historically democratic, that are now really in the throes of a crisis of democracy, we can understand more profoundly the opportunities for protest, the opportunities for civic engagement, and the opportunities that we've highlighted and will be going into again next week about how each citizen now has to take an active role in the democratic process because democracy needs to be renewed every generation as we deal with circumstances that are afflicting us and compelling us to dig deep into the chaos, to seize the opportunity for a greater coherence. And that's the challenge of Humanity Rising. And that's one reason why we blend as often as we can what's going on externally, which happens to be rising turbulence all around the world, as we all know, so that every day and every week, we can also plumb the depths of that chaos to discern the opportunities that will create a greater coherence. And that's why we go into all kinds of nooks and crannies of the world. Yesterday with Heather Ashamara, looking at the Toltec spirituality and how that can inform us to lead lives of impeccability and lives in which we gather all our energy, which is dissipated by the chaos. But they're processes like recapitulation. And we're going to have a whole session on recapitulation in a little while so that we can learn to gather our energy into ourselves so that we can create more coherence into the world. And that's what we're doing at Humanity Rising. It holds the contradictions within a larger whole, what Jung called the antinomial nature of reality. That it's possible to have multiple truths simultaneously that appear to be completely disconnected and exclusive of one another, but actually are part of a larger whole, that if you understand the whole, you can bring redemption through the crucifixion of the ego, as Jung said, a redemption that transforms your soul through the process of what he called individuation, as the ego surrenders to the healing power of the self. That's why we breathe together every day and meditate together, so that we can learn a very powerful practice that will enable us to create an internal coherence that draws from the chaos. You're breathing in, you're breathing out. You're enabling your whole somatic, psychological, and emotional and mental system to cohere in a healing way with greater internal synergy and equilibrium. So in that spirit, I just wanted to welcome all of you. And now let us deepen our coherence before we go into the vastness of the cosmos in a few moments with an astrophysicist and cosmologist. But always start, as we do, with just breathing together. So for those of you who are new, in a moment, you're going to hear the sound of a bell. When you hear that bell, just start to breathe in. About 5.5 seconds. You'll hear another bell and just breathe out. We're going to take 10 breaths together. Thank you, everyone. Let us breathe as one. Thank you, everyone. Now, in the spirit of coherence, it's my great pleasure to introduce someone I've gotten to know through Humanity Rising and the Wisdom School, Kala Perkins, who's been on Humanity Rising before. If anybody I would describe as a Renaissance woman, it is Kala. Her life spans the globe. Last week, she was in Haifa for an astronomical conference, and she was in California. And today she's in Hawaii for another astrophysical conference. She has deep training for many decades in the interface between the latest researches of science into the cosmos in which we find ourselves in astrophysics, with ancient mythology, ancient spirituality, mindfulness, in a journey of a lifetime, which has brought her into understanding more deeply the awareness that the ancient mystics had about a unitary cosmos, and the latest researches of cosmology that are day by day and evidence by evidence showing that the ancient insights and intuitions about the nature of being were essentially correct. And so she's going to give us a briefing today on the latest advances in cosmological research. And she told us while we were waiting for the program, she has so much material that she can't get through it all. So we're going to have her back. So rest assured, we're going to get the whole dose, but we'll have to do it in stages because this woman has so much information and such deep wisdom that she's going to share with us. So Kala, thank you so much for getting up so early in Hawaii. And I turn the program over to you.
Thank you so much, Jim. I'm going to find my screen share here. And before I do, I just want to say how wonderful the chaos. So cosmos emerges out of chaos. That's the classical reality. It's the classical story of how you have to find the chaos in order to let the cosmos emerge. And one of my very favorite ideas in all of that is the sun. So the random walk of a particle from the center of the sun, where a single photon escapes as the electron shifts from one atom somewhere in the middle of the sun, takes approximately 65,000 years before that photon, going completely, quote unquote, randomly or chaotically around the sun, before that photon escapes and becomes a ray of light, part of a ray of light that shines out into the universe. And all of us, all the life of the world, is the cosmos that has emerged from all of this chaos. It's beautiful. It's very beautiful and so true what you were saying. All right, so here we go. We are now looking at an update. I'm working with this here. Okay, that's fine. This is what I want. One moment, please, here, and I will remove the images for you to be able to see the pictures. Okay, that's better. All right, so we are going on an update from the infinite with new eyes on the universe and the aeronautical thrust for space tourism, ecological considerations for spaceship Earth. So off we go, and the beautiful mirror here in the center, which many of you may know about, I'm sure, is the James Webb Telescope mirror. It is made like a honeycomb, and we're going to see what it's made of. It's gold-coated, literally gold-coated. So we will look at that in just a moment. The background picture that we have here is the cosmos. We are looking at James Webb's first image of the universe, the deep field that it took for 2.5 hours only compared to the Hubble Space Telescope's field. So let's go on our journey and see what we have here. It is an amazing image, and the pictures that the Webb has been taken have taken the world and the scientists by storm. So the Webb launched on December 25th, 2021, pardon me. It's jumping ahead here. 2021 on an Ariane rocket by the European Space Association. This is the beautiful mirror, an idea of it floating up above the Earth, and the clean room where they made it. I was just at a conference in Boulder, Colorado, and we went to the clean room where they actually built the telescope and built the mirror, and they still have dynamics there in Boulder that are communicating with the telescope in space as it's already launched out there. John Mather is the senior project scientist, and in January at the American Astronomical Society, he gave us an update on the Webb and its history, and his emphasis was it's all about the people. And he's talking about where we're going next. And the idea, inclusion, diversity, equity, and accessibility is very, very key at the forefront of astronomy these days. They're trying to heal whatever was there that kept everyone from being able to participate in this amazing journey of being part of the cosmos. NASA actually had a project with Reddit asking the women with diverse jobs on the James Webb Telescope to answer questions about their experience. So there's a very, very strong emphasis on inclusion and community. So here we go. The James Webb and the Hubble are complementary. The Hubble is in visible light. It takes pictures a little bit also in the ultraviolet. The James Webb takes pictures in the infrared, the heat, and a little tiny, tiny bit toward the red color of the spectrum. So it's mostly taking images through the dust and gas to see the heat sources coming from within the stars and the galaxies. Hubble is in a low Earth orbit, 340 miles up. It gets Earth's reflected light and heat. And James Webb must be cooled. So it's at 1.5 million kilometers, about 1 million miles away from the Earth. And it orbits the sun in a year, just like the planet, in order for it to capture the infrared light. So Hubble's mirror, its primary mirror, is 2.4 meters with glass and aluminum coating. James Webb's mirror, we will catch this. James Webb's mirror is 6.5 meters with beryllium segments and gold coating to be able to get the infrared light in the best way possible. This is the Hubble Deep Field. It took 2 weeks for us to get this amazing image that took the world by storm. But this is the James Webb's Deep Field that we had on our original slide. Pardon me, it was 12.5 hours that it took to get this amazing picture of the power, the heat, and the fire inside all of these stars. So we have some amazing pictures that have been coming from the Webb Telescope, and I'm sure many of you have seen these. We're one of our images here, it's just that star is about to supernova, and we see right into its core where this huge, powerful star is just about to explode. The dust and gas from its outer shells have already been thrown off. This image here is brilliant. It's the a Wolf-Rayet star, WR140 they call it, and these rings here are dust. There are 2 stars orbiting each other in this loving dance where one has a black hole in the center, the other orbits, and some of the dust and gas falls in to that first star as it orbits around and around. And it's created these amazing ripples of dust as it orbits that the Webb has captured. And eventually the star will merge with the other star. So it's a dance of union. that we have, the Wolf-Rayet stars. And this particular one is 5,600,000 light years away, that image. We have another dance of stars here below it. So Webb is also taking us on an amazing journey of finding new exoplanets, planets that are out in the universe, going around other stars that may or may not have life, with all the dynamics that they do with their own parent star. MIRI is the mid-infrared camera, the mid-infrared instrument. NIRCam is the near-infrared camera, when you see those or when I mention them. So it's seeking to identify known elements in the atmospheres, the signatures of possible life, the spectroscopy is how we find which elements are in space, in exoplanet atmospheres, in new star-forming regions. Each molecule has its own fingerprint that we can identify as we break the light coming from it into its spectrum. So we're finding oxygen and carbon in these distant planets. We haven't found life yet, but we actually recently found an Earth-sized planet, which is really exciting. So we give all these planets, just like the stars, telephone numbers, shall I say. So in November 22, WASP 39b was discovered using the Webb. It's a hot giant about the same size as Saturn. These images are artists' images of the planets because we can't see them, but we have the data of their energy. The first observation was they found sulfur dioxide and photochemistry, where chemical changes influence the starlight in an exoplanet atmosphere, just like on the Earth. We have LHS 475b. It's a terrestrial planet orbiting the star for LHS 475 at about 40.7 light years away from us in the constellation Octans. This was just found, and there was a lot of excitement. It was one of the first extrasolar planets to be confirmed, and it completes an orbit every 2 days, and it's 99% the diameter of the Earth. So there is a similarity, but it's much closer to its star. And WASP 96b over here is larger than Jupiter. We found water vapor on it. It has a 3.4-day orbit in its star relative to Earth. There's carbon dioxide, there's sulfur dioxide. It's also things that are found in Earth's atmosphere. So the universe is made of stuff just like we're made. And it's amazing to think that there isn't other life similar or different than our own out there in the universe. This is Webb's picture of Jupiter. And we see the poles, we see the aurora at the poles of Jupiter. We see these incredible definitions of the atmosphere and the contours, all of it, the spots. It's a remarkable picture of Jupiter that we just now have. I put in Enceladus here, one of the moons of Saturn, because James Webb is going to look at these incredible plumes of ice and gas and water vapor coming off of the south pole of Enceladus, because we're looking for life there. Well, the NASA mission found that it has a thick layer of ice with a vast, warm, saltwater ocean outgassing methane, which is a gas that we have here, and it comes from microbes on the Earth. The methane was discovered when the mission's Cassini spacecraft flew through giant water plumes erupting from the surface of Enceladus. So Webb is going to look at that again and see what we find. We have the idea that there must be some kind of life like the early life that came in the oceans of the Earth, of our Earth. So this is Neptune. The first image we had, Voyager in 89, Hubble in 21, and this incredible picture in 2022 from the James Webb with the rings orbiting Neptune and all the definition of its atmosphere. So the cosmic cliffs in the Karina Nebula, this is a very active new star birthing area. And we have pictures from the Hubble. This is the James Webb, the MIRI and NIRCam images together. There are amazing things that we can see right through the dust and gas. These are new baby stars being born, and there's jets coming off of them as they're forming their nebula, and maybe planets around them. Maybe these are new solar systems in the process of forming. And it's remarkable, the ability with which we can see through and into. It's like having a sound image of the baby as it's forming in the mother's womb, an ultrasound of the baby stars in formation. So this is another new star forming area in the small Magellanic Cloud, which is an orbiting galaxy, a small companion galaxy to our Milky Way. It's a satellite galaxy. What we found is that there are the possible building blocks of life in some of the very earliest stars, which surprised us greatly as we can take the spectra of these new forming stars of different ages and in different types of dust clouds in space. So here we have our deep field, our Carina Nebula, and a ring nebula of a star that died, just like our sun will, in the depths of space. We have the image from the Hubble on the right side and the image from the Webb on the left side. So it's seeing a different contour. It's seeing different elements as it looks deeper into the dust and gas. And here we have Stephan's quintet, 5 galaxies. One is actually a nearer galaxy, but this group of galaxies that in this collective dance together. And we've never seen it before so deeply. It's a very remarkable quintet. And with Webb, we can see even more the dynamics and the relationship of the dust and gas as these stars orbit, as these galaxies orbit. And eventually they will most probably merge, the black holes in them, drawing them together. So these are some of the amazing interacting galaxies that are in the process of merging, that that James Webb has given us these images of. It's amazing, the depth of structure that we can see in their core. We can see right into the center, into the heart of these galaxies. We understand that there is a black hole in almost all galaxies. It's covered by the dust and the gas that is being pulled in by gravity and the energy that's being thrown out. And we'll look more at these dynamics as we go on our journey here. So this is amazing that we see all these red regions, the hydrogen clumps where new star formation is going on in this galaxy around its radiant core. This is another star forming region that we have from the Webb. And I'm just wanting you to be able to be bathed in some of this incredible elegance that's being shown to us and the way they're contouring and structuring the images. The colors are not real. This is the artistry of the astronomers. Astronomers and art, science and art is very much merged in the modern day astronomical adventure. So this is literally a photograph, 2 photographs of the amazing star forming arms of we're called NGC 628, 32 million light years away, and NGC 1566. So I just want you to bathe in this incredible structure and beauty. Jim was saying that the cosmos, the order, the coherence comes out of the chaos. So these beautiful galaxies form from dust clouds. And in the universe, the first step of cosmos is decoherence, is that breaking of the symmetry of the great vast unity. The symmetry has to break. There has to be positive and negative, electron and proton, electron and positron, for the whole dynamics of the universe to emerge out of the ensuing chaos of energy that swirls and creates particles, and the particles collide and create this incredible dance and dynamic over the billions of years of the universe. And out of this incredible chaos emerges these amazing spiral galaxies. It's like the inherent dynamics of the cosmos are there before and in the chaos and just waiting to emerge, like life itself and all of us. These gorgeous images. We have more galaxies here. We see just into the center, the nebula at the core of these galaxies and the dust and gas. This is a Hubble image of one of these spiral galaxies, and then we see it in its infrared light from the James Webb Telescope. So we can see these incredible the bar at the center and the arms spinning out, and then we see into the arms and see the star formation actually happening. And we're learning about the relationship from the core to the arms and the star formation. So James Webb Telescope just discovered the furthest galaxies so far. These are images up here of these very distant galaxies. They're redshifted to the red end of the spectrum, the long end of the spectrum, because they're very far away from us. The light has traveled a very long time. Blue means that something is coming toward us in the light. So this is the deepest galaxy that we found, the furthest away. It's actually only 325 million years after the Big Bang. About 33 billion light years from Earth. We're calling it GSZ130. So that's its phone number. It was discovered as part of the Advanced Deep Intergalactic Extragalactic Survey by the UK universities, Dr. Emma Curtis Lake and her colleagues. We're reaching very, very far into the depths of our universe, very close to the earliest images, the earliest formations, the earliest structures in our universe. And of course, we don't know if there were infinite universes before, if there are concurrently infinite universes as we speak that are either in dialogue or not with our universe. Maybe it is a multiverse of galaxies and stars and universes. These are all questions that still linger for us. So Loafar, now I have to tell you, Loafar is one of my favorite telescopes. It is not so complicated as many of these amazing, huge structures that have taken billions of dollars to build, but it is a low frequency array telescope that spans 7 or 8 European countries. It is in the ground almost, and it is taking low frequency radio telescope images. It was created originally in the Netherlands. As of 2019, it's in 7 countries. It's coming into Italy. So it consists of a vast array of omnidirectional radio antennas using about 20,000 small antennas concentrated in 52 stations, including Germany, Poland, France, Great Britain, Latvia, Ireland, Sweden, and Italy. So what it's doing, it's an interferometer. It's collecting all the light from specific sources that hit this wide berth of area, combining them together and getting amazing images, the lowest frequency of radio, the furthest away in these in the universe of these amazing galaxies. It's capable of detecting the most distant massive galaxies and will study the processes by which the earliest structures formed in the universe. It also studies the global magnetic fields in our own and nearby galaxies, in galaxy clusters, and in the intergalactic medium. So this is the deep field of Loafar. Every single dot here is a distant radio galaxy. This is not a plain image. It is a structured image, all these little dots of light. Here we have a little cluster, and we see these huge jets coming out of this tiny, it looks like a tiny galaxy, but it's a huge, gigantic galaxy. And it's throwing out these massive jets that we see in radio frequency from the dynamics of the black hole in the center. There's a huge spinning black hole in the middle of these galaxies that's throwing out this dust and gas as it draws in the stars and the dust and gas from its galaxy. So this is one of the most amazing. Here we have this collection of galaxies throwing out their jets and dust. And one of these, again, with these incredible structures as the black hole spins. And so I was just at one of these meetings where we were studying how the black hole influences star formation and the jets and the evolution of the whole galaxy over time. So these are we're really penetrating into and understanding the depths of these dynamics that have given rise to our universe, that are happening, and that henceforth gives rise to life. And I think there's something like 20 million of these galaxies that Loafar has discovered and is peering into the black holes. So we're at an incredibly new frontier of studying the dynamics of black holes in the universe and how they interact with the process of cosmic evolution. Also, we have many new gravitational lenses in galaxy clusters. So I told you we're going out to the edge of the infinite here, and here we are. So gravitational lenses are when we see these beautiful arcs here. This is from the James Webb. This one also, we see these arcs here of light. This is an image from one of our other telescopes. And we take these arcs of light. They are coming from some distant quasars, huge early forming galaxies. And the gravity of this huge cluster in front is bending the light around it with its dark energy and dark matter. And what the astronomers do is they will add the arcs together. They'll add the light together and find out what is that distant object, that quasar out in the early universe beyond the galaxy cluster. And they will get an image of it. They will get an idea of what that quasar looks like, what it's made of, how long its light has been traveling. So these are a group of new gravitational lenses that were found 1,200 of them using machine learning in Australia, looking at the dark energy spectroscopic survey. So the universe is vast. It is amazing. It is radiant, filled with light and dynamics and beauty, and an arabesque of the eternal in its emergence of cosmos from chaos, as Jim was saying. So the Indian astrophysicists in India just discovered the most distant galaxy cluster yet. And we have it here in the background in radio frequency. It was discovered using the Sloan Digital Sky Survey data. There are approximately 400 billion, it's approximately 400 billion light years away in the direction of the constellation Pisces. It is estimated to possess the mass equivalent to over 20 million suns, being 600 million light years across, or yes, approximately 600 or 650, while the Milky Way is about 150,000 light years across. The Laniakea supercluster, which was the largest that we knew before, 500 million light years, is where our Milky Way is found. So this one is 600 million light years. So what a supercluster is, it's composed of chains of galaxies and chains of galaxy clusters, tens of millions of galaxies. With this one has 43 clusters linked in a network, in a web, like a brain of neurons of galaxies. in the cosmos. So we're aware now of another great aspect of the cosmic neural being, and it's dynamics. All right, so now we're going to look at the Atacama Cosmology Telescope. And as Jim mentioned, so I'm only giving you a little taste of some of these remarkable things that are coming from our different surveys, from our different cosmology telescopes. And there are new ones that are happening incessantly. And we'll see with our exoplanets, every other day we get a new calculation of how many exoplanets we found. But here, the Atacama Cosmology Telescope. So this is in the north of Chile, in the Atacama Desert, the high desert. It is looking at the gravitational lensing of the cosmic microwave background. So how did we get all this structure? How did it bend? What is the process that the earliest structures in the universe emerged from? And this is our the latest images of our cosmic microwave background with Planck, the progression, Kobe, WMAP, and Planck. So it's detecting the lensing where the photons are slightly bent, and this gives rise to the first structure in our universe. The image is 380,000 years after the Big Bang. So we have a new era of black hole astrophysics, as I was mentioning. Recent developments have launched us into this domain, providing direct viewing of the remarkable environments near the black hole's event horizon. These observations have enabled astronomers to confirm long-standing ideas about the physics of gas flowing back into the black holes with temperatures that are hundreds of times greater than that at the center of the sun. At the same time, the observations have conclusively shown that light rays near the black hole experience huge deflections of light that cause shadows in the central image, with an effect which is an effect predicted by Einstein's theory of general relativity, confirming it yet again. With further investment, this field is poised to deliver decades of advances in our understanding of gravity and black holes through stringent tests of general relativity, as well as insights into the role of black holes as the central engines powering a wide range of astronomical phenomena. And one of our guides here asked me at the beginning of, but just before we started, why don't the black holes eat up the whole universe? So the black hole can only contain as much as the gravitational force that it has. There are stellar mass black holes, gravitational black holes, huge black holes in the center of galaxies. And there may be black holes that we don't even yet know about. But the understanding that we have now is that eventually, in billions of light years, those black holes will merge from galaxies and galaxy clusters, and eventually merge back into the night of cosmos. And then, according to the Hindu philosophy, it says the night of the universe, the pralaya, is equal to the day of the universe. So it all merges back into the darkness, sleeps for a while like we do, as above, so below. And then it says the universe sings again or breathes out again, and the universe ensues. A new universe emerges. So our understanding so far of the East and the West in black hole dynamics. So astronomers using the Gemini North Telescope on Hawaii, where I am at the moment, revealed the first nearby dormant stellar mass black hole. And this is not a photograph, that is an exquisite art rendition, but it shows the dynamics as accurately as possible. They detected this stellar mass dormant black hole. It's the closest one to Earth that we've found yet. It's in the Milky Way. It presents an exciting opportunity for us to study black holes at this scale. It's only 1,600 light years away and can provide insights into the evolution of binary stars. So an AGN I was showing you my favorite telescope, Loafar. I love all the telescopes, but Loafar is giving us a lot of these incredible images of the AGN, the active galactic nuclei, and the galaxies that host these nuclei with huge black holes and these amazing jets that are flowing out of them. And we spoke about this, the radio frequency jets flowing out from the dynamic black hole in the center. And here we see this combination of radio light and visible light and X-ray light, giving us this incredible insight and beautiful image as well into the dynamics that are happening in this galaxy. We also have them in circular galaxies, and the dynamics are very different. And it also depends which orientation is the jet toward us. Is it vertical? Is it coming straight toward us? What is the angle of the galaxy with relation to us? What is the image thereby that we receive? So these are the binary galaxies, dual activity of galaxies in the optical, that we're seeing these colliding galaxies, and we're looking into the nuclei, the incredible gravity that's bringing these two galaxies, this dance of merging galaxies that we have in the universe, and the cores and the black holes in the core of them that are bringing them into dialogue and into dance and into mergers, eventual mergers. And here we have this, we watch this curvature of the jets because of the dynamics of the black hole at the center. Okay, so to the edge of the universe and back home. Helios, the sun, life with our living star. On March 12th, a week ago, 2 weeks, something like that, sun monitoring spacecraft recorded a huge amount of material blasting away from the far side of the sun from a coronal mass ejection. It was detected as an expanding cloud or a halo of solar debris, and it raced away from the sun at exceptionally high speeds of 2,127 kilometers, 1,321 miles per second, and it impacted our atmosphere because it was so intense, that expanding coronal mass ejection. This is an image that they have of the coronal mass ejections, that energy, it spreads out through space. And because this one was so active, so dynamic, in 2025, the sun is, it's in the, going into maximum activity, and it will reach the high point of its 11-year cycle. 2025 will be the high point, the midpoint of activity, the highest point in this particular cycle. Every 11 years, the sunspots start at the poles and move toward the center over 11 years. And then there's a height of sunspot activity. So 2 more years, it will reach that height in this cycle. And then it calms again and goes into the quiet sun cycle. So another amazing dynamic that just happened a few days ago was there was a 111-mile-tall solar tornado. It's one of the largest plasma twisters that we've ever seen anywhere. I mean, there's a lot we haven't seen, but this is in our local universe. This huge twister came out of the North Pole of the sun. It's a massive solar tornado towering over the sun's North Pole for 3 days. It stayed there for 3 days at the sun's North Pole. Wait a minute, we're jumping around the cosmos. And it sent the plasma twister, it was rotating, and it created a huge magnetic field spinning around at the North Pole of the sun. And this was March 18th. That we have this amazing image. So people are watching, our astronomers, their eyes are growing, their eyes are opening, and it's amazing to realize the depth of the understanding that we have now about our universe, and that we can within a day or a couple of hours, we can see there's another flare on the sun. There's another dynamic going on, because there are solar astronomers who have focused their whole life on understanding of the sun and watching it, or a certain galaxy, or a certain group of galaxies or planets or dynamics, or new star forming areas. So we're in an amazing, amazing era, and everyone is invited to participate. There are tremendous resources on the web, in the internet, on YouTube, if you want to explore these things more. So we go from our sun, we're coming back to our Earth now. This is an amazing aurora with the caress of the solar wind at the poles of the Earth, creates these aurora from the magnetic field of the Earth as the solar wind impacts the North Pole, and it creates these incredible magnetic fields and dynamics that result in the aurora. And that magnetic field protects us from having our atmosphere blown away from the Earth by the solar wind. But we have these beautiful images. This was taken from the International Space Station. All right, we are back on our Earth. I'm bringing you back so that when you leave this presentation, you are not lost in space. So I would love to be able, I don't know if I can do this. Hi again, everyone. Okay, so maybe, I think it's going to be better if I'll put this down here. Okay, it's better if I leave it this way, then you can see better. All right, light pollution. We are back on Earth. Who hasn't been up in a mountain or driving through a city at night, and the glow of the lights are everywhere? We live immersed in light. And what does this mean? It's a great victory at some level that we have power and electricity and light, just like we have cars and oil and transportation and whatever we're using. But what is this light doing, and how could we make it better? What is biodiversity? How is it affecting all the biodiversity intensely with this light pollution, including migratory species, birds, insects, and other wildlife? Artificial light has several general effects on wildlife. It attracts organisms, moths, frogs, sea turtles, resulting in them not being where they should be, concentrating them as a food source to be preyed upon, or resulting in a trap which exhausts and kills them. The little turtles, rather than going toward the moon when they hatch and the ocean, sometimes go back up the beach to the lights from the buildings, and they die on the shores because they haven't followed their natural instinct to go to follow the light of the moon. These unnatural light-induced behaviors can mean that migratory birds end up depleting their energy reserves as they're confused, and it puts them at risk of exhaustion, predation, and lethal collisions with buildings and other man-made structures. Millions of birds die every year crashing into buildings because of the lights when they're trying to migrate according to the star patterns and the sun and the magnetic field of the Earth. This is an incredibly complicated and deep field that has now emerged. We're realizing that we can create our lights focused down. We can use amber colored lights rather than blue lights. Now we're getting this whole movement to bright blue light, and it's worse for the human body. It's also worse for nature, for these nocturnal animals that are then doused in light and they can't find mates. It's a really complex ecological crisis that we're going through. Here in the back, we see the lights of the Earth at night everywhere. Very few places relatively are still dark where these animals can live according to their natural cycles. The World Migratory Bird Day, dim the lights for the birds at night. Even if you have in your own home, don't leave the lights on at night outside in your garden, because the animals, the creatures, will fare much more according to their natural cycles. It's also much better for the human health and for all animals, creatures' health. People all over the world are living under the nighttime glow of artificial light. It's causing big problems for humans, wildlife, and the environment. There's a global movement to reduce this light pollution. And everyone, every single person, everywhere we live, our communities, we can talk to people. I spoke to the new mayor of San Mateo, and they were totally unaware about the problems for animals and creatures and human beings also from this light pollution. Also, when was the last time you saw the Milky Way? The whole evolution of Earth, for 4.5 billion years, we've lived under the stars. We lived under the arc of the Milky Way nightly. And it's now a rare occurrence. There are people who grow up their whole lives and maybe don't even see the Milky Way, or unless they go to the mountains or get out in the cities or go to the dark beaches that aren't lit. So it's amazing how we're shifting our human psyche with light pollution. From the National Geographic study, an increased amount of light at night lowers melatonin production, which results in sleep deprivation, fatigue, headaches, stress, anxiety, and other health problems. Recent studies also show that reduced melatonin level can be is correlated to cancer. So sleep in the darkness, close your windows, seek to have some experience when you're sleeping of real darkness, because it's what our bodies are used to. It's the natural cycles of life. Another challenge that we have here on our Earth connected to space, SpaceX satellites and others are marring Hubble's vision. So a rising number of images by famed telescopes, include satellite trails, because all these satellites are up in space. This image is just one. That's the Hubble Space Telescope. A growing number of satellites circling the Earth will interfere with observations from all astronomical telescopes. This curving light streak is created by an artificial satellite, and it interferes with the beauty of taking the images of the universe. That's from the Hubble. Check this out. This is ground-based telescopes, what they're seeing with all of our hundreds now and eventually thousands planned by SpaceX Starlink, so that everyone in the world can have 5G in the most remote jungle. These are images that are being taken now by our ground-based telescopes with the satellite interference. The recent launch of low Earth orbit satellite constellations is creating a growing threat for astronomical observations with ground-based telescopes that has alarmed the astronomical community. Is this the image you want to see from all our research? The observations are affected by the artificial satellites. They can become unstable for scientific research, unusable for scientific research due to the satellite contamination. There are conversations going on with SpaceX and Starlink now to try and mitigate some of this. They've offered to paint the bottom of their satellites black so it doesn't reflect the light from all the light pollution on the Earth, which is part of what is happening with these metallic satellites. So we are in an interesting moment with regard to how we see our world. One more thing that we will embark upon looking at with regard to our universe and our space and our Earth is space tourism. So first of all, we have some amazing, a whole new development of the space industry, the aerospace industry. SpaceX launched the last, the astronauts and cosmonauts up to the International Space Station. The commercial space industry has been able to do many things that the national space industries were not. And NASA is now turning over the development of further space aeronautics to the space industry. Virgin Galactic, Space Adventures, Blue Origins, and it is a multi-billion-dollar industry at the same time. And one of their main objectives, along with taking people out into space who are officially astronauts and letting people do scientific experiments in zero gravity, is space tourism. I quote from one of the companies we will see more of in a moment: "The space experience you've waited for your whole life. Travel to space in a luxury capsule with family and friends. Start your adventure today. Over 500 seats are already reserved. Cabinet for belongings, room for 8 explorers, 360-degree views, Wi-Fi enabled, refreshment bar, reclining plush seats, 0 emissions." This is the top, this is the best, that it has 0 emissions. 6-hour flight time, wheelchair accessible amenities, Wi-Fi, restrooms available, bar on board, post-flight celebration, 100% refundable deposit. These are happening now. Already people are buying tickets to space. Companies including SpaceX, Virgin Galactic, Space Adventures want to make space tourism much more common. Our first space civilian tourists have already orbited the Earth with Inspiration 4, which many of you may know about on SpaceX. Just one woman who was part of this, she was a child cancer survivor. There was another man who'd been a pilot. I can't remember the other two, but it's the adventure, and you don't need to read all of this. The adventure has become accessible for people. We've had more groups of civilians going up in space, and it's becoming much more common. But the question is space tourism the next big adventure or the next big disaster? And I've put all these things here mostly for me to share with you. You can glance at it as you like. Please excuse me for the crowded slides. So as innovation, exciting and lucrative as it may sound, commercial space travel by civilians has its dangers, not only for humans, but also for the planet. In November, Congress voted to approve the US Commercial Space Launch Competitive Act, which limits regulatory oversight for at least 8 more years, temporarily putting responsibility on passengers and companies. The innovation is amazing, but the lack of regulation is really dangerous. So in the past 2 years, the industry has experienced 3 catastrophic failures. 2 rockets exploded, 1 test flight crashed, and there was the death of a pilot. But that's only the beginning. We're hoping that they solve these problems. But one very great problem is the impact of space travel on our planet for all humans, plants, and animals, putting us all at risk. There is soot that accumulates with every launch in the stratosphere, approximately 5 to 31 miles above the Earth, and it can't be washed away by rain or winds. It's in the lower atmosphere. As a result, black carbon may linger in the stratosphere for years, causing exponentially more climate change. Some studies estimating the potential soot accumulation based on assumed demand levels and simulations reveal a grim picture, including massive sea ice loss, ozone layer depletion, and temperatures increasing. So as of now, neither space law nor current environmental law respond sufficiently to the environmental threat posed by this industry. As long as the space tourism industry is developed without the necessary cautions, it remains at risk of becoming the most unsustainable tourism sector with negative impacts on our home planet. So, why is this happening, and what are the questions? Ecology and the economy, the eco, our home of space flight. New research shows that increased space travel could undo efforts to repair the hole in the ozone layer. Successful global coordination to ban harmful chlorofluorocarbon gases and restore the ozone was a rare climate triumph, but it can be, but can it be replicated? The rocket launches are challenging this. As rockets blast into space, as I mentioned, they send off this black carbon into the stratosphere. It absorbs sunlight, it radiates heat for up to 4 years before falling back to the Earth. Researchers in New Zealand have warned that the expected increases in space travel are likely to damage the ozone layer if action is not taken. But where are we going? It's like our oil industry. The World Bank, in a report last year, estimated that space tourism with both suborbital and orbital flights together has a potential market value of $3 billion by 2030. More recently, the space industry consultancy Northern Sky Research broke out its expectations for suborbital space tourism versus orbital tourism. Research broke out its expectations. By 2028, they expect suborbital would be a $2.8 billion market with $10.4 billion in total revenue over the next decade, while orbital would be $610 million, going up into the billions in total revenue, 3.6 billion in total revenue over the next decade. So we're looking again at the ecology and the economy. But there is promise. Renewable rocket fuels going green and into space. It seems that propellants used to leave Earth's gravity may not be fully green with zero environmental impact for some time, but that doesn't mean that they can't be carbon neutral. They are thinking about synthesizing fuel from renewable sources of energy, even some things like bacteria, to carry large-scale electrolysis, splitting water into hydrogen and oxygen components through a photochemical process to create hydroxyl and hydrogen and oxygen fuels, which will be less polluting. Solar energy harvested from 600 square kilometers somewhere in the Australian outback could cover the entire global energy demand in all forms. Why aren't we doing this is the question. This requires conversion technologies that go beyond electricity to create energy carriers, such as chemical fuels. Carbon neutral fuels could be used in rocket fuel production and could indirectly reduce the net climate impact of rockets, but their entire production pipeline would need to be considered truly carbon neutral. This is really key and really important because our windmills and much of our solar power is created with processes that are creating as much pollution as they're solving. So this is a really, really important element. In the case of carbon neutral fuels, we also have to consider the sustainable technologies for water and the atmosphere to be truly sustainable. Bacteria as a sustainable fuel is being considered. There are 144 orbital rocket launches attempted in 2021, which is a record, and the number just keeps going up. Everyone seems to want to go to space. Many people have already bought tickets. They're wanting to get it down to $40,000. It is not that price yet. It's in the millions, but many people have that ability on our Earth right now. The demand is higher than ever. That's why the industry is taking note of the environmental impacts of rocket fuel, seeking more sustainable alternatives. Biofuels are of huge interest because they are less harmful to the environment. One promising option from Lawrence Berkeley National Lab promises more energy density than any current fuel option available without the toxic byproduct of petroleum. How would this biofuel work, and what are the downsides and the upsides? We need to find out. All right, on the more interesting side here, space colonies we're talking about, And we've been talking about it for years. Martian settlements, settlements on the moon, and space medicine. So when I went to this last conference, the people were talking about all this, and a thought came to my mind. Can humans procreate in space? Can babies be born in space? If we have a settlement on Mars that takes a month or so to get there, and people end up living there? But so far, we don't think so. They don't think that implantation is possible in zero gravity. The fetus requires gravity for the heart, the bones, and the body to form. We've pretty much established that we can survive for prolonged periods of time floating in outer space, but we haven't even come close to comprehending the thought of a human being born in that environment. Astronauts are trained individuals at the height of human fitness, backed up by a lot of research and experience to guide them. But a human infant has none of those qualifications, making it far more difficult to survive. Even if it survives, it's highly probable that it would not be improbable that it would be a healthy individual because of the way the body forms, the exercise. I remember when my nephew's first child was born, and they kept putting him on his belly and making him raise his feet and raise his head so the child would get that exercise, and the muscles would form, and the bones and bone structure would form, and the whole coordination of the nervous system and the central nervous system and the autonomic nervous system with these relationships. But none of that would happen in zero gravity naturally, certainly. So the current science indicates that it might not be wise, from all the studies of the effects of microgravity on fetal development in rats, geckos, sea urchins, and even birds. Viability was usually lower, and sometimes unusual abnormalities cropped up. So that's another something for us to take into consideration when we're talking about space settlements. And I'm not being discouraging, but these are important things for us to consider if we're thinking of a settlement on Mars. So, space perspective. This is propelled by a space balloon. It is technology used for decades by the likes of NASA. Spaceship Neptune is the first carbon neutral way to travel to space. It is a space balloon. People are already booking. They have an advertisement on their website, Space Perspective. Book now. They are the ones whose quote I had about how you want to have Wi-Fi and luxury seats and a bar as your space balloon goes up to not orbit, but into the higher stratosphere. So you can have a few moments of experiencing zero gravity and be able to look back at the Earth and see the beauty of our home planet. This is one of the motivations of space tourism, which is a beautiful motivation to become inspired with taking care of our home planet, but we have to be responsible for how we do this adventure. All right, I'm briefly going to go through this and then I'll bring you to a conclusion. Space junk. We have done the same thing with outer space, believe it or not, that we did with the oceans and our Earth. There are roughly 500,000 objects between 1 and 10 centimeters in diameter orbiting the Earth. And there are more than 100 million particles larger than 1 millimeter. NASA says there are more than 9,000 metric tons of junk, old satellites that died, some that were shattered and broke into little bits and are threatening other orbiting satellites, all kinds of stuff that we've put up that we didn't assure would fall down and burn up in the atmosphere. There are more than 6,000 active satellites rotating around the Earth for our weather, for our television, for our internet, for GPS. Every time you put into Apple Maps or Google Maps or Waze how you want to go, it is because of a satellite that's working. When you call your friend or we're doing Zoom here from Hawaii to wherever you are in the world, this is because of one of these 6,000 active satellites rotating around the Earth in low Earth orbit. Some are the size of a shoebox. Universities are sending up their own exploratory experiments and satellites. Even school children can send up experiments on some of these launching satellites. Their functions, as I said, vary widely. Satellites can't live forever. They run out of fuel, they malfunction, they become pieces of garbage whizzing around the Earth. There are more than 1,800 defunct satellites in lower Earth orbit. It's shocking to think we've done this to our atmosphere. Under the current rules, the United States requires satellites to burn up in Earth's atmosphere after 25 years, but that regulation is very lax. The satellite should be deorbited earlier. Thankfully, there are a number of steps governments and companies are taking to curb the problem of space junk. Biden administration has called for a ban on all destructive anti-satellite tests because recently the Pentagon launched a program called Orbital Prime under the US Space Force that will give companies seed money to develop the technology they need to clean up space. Okay, another issue that I'm not going to go too much into is Space Force with the US, the new development of the US Air Force has developed its own Space Force to keep our space safe, so to speak, but there are many challenges with all of that. All right, so we come to where are we now? We have our Earth from space as a giant heart floating in space for us, the pulse of our own heart, deeply connected to it. Many of our real questions remain. Are we alone in the universe? Is life either as we know it or differently based and evolved, unique or ubiquitous in cosmos? Is the universe itself alive? Perhaps a single cell in an infinity of universes, the multiverse? What is the reason and role of life and consciousness in cosmos? How does life serve and feed back into the universe? What will it take to bring our humanity to treasure life and our precious, amazing spaceship Earth, our harbor and abode, and life itself above all our vanity, carelessness, and ecological genocide? Thank you. All right. I will quit my screen share now. Hello, Jim.
Kala, that was a tour de force.
Yes. Yeah.
I think Judith called it, wow, talk about needing to be humbled. When you just think about everything we're doing, polluting, commercializing our immediate cosmic environment against the vastness and the beauty and the intricacy and the complexity and the wonder. It's like we humans are somehow, I don't know what the disconnect is, but you would think that going into outer space, the wonder of it all would humble us enough to get us to at least stop polluting.
It's shocking. It's very, very shocking. I keep saying more and more as I experience and encounter these things, what are we? How is it possible that we don't make life the most central, cherished thing? How can we have, we're from San Francisco, our streets. Oh my God, the people living on our streets. What does it take in the universe to make this being that has consciousness, let alone the biology, the sentience? And yet, what are we doing? And one of the most shocking things to me at this level is leadership. Most of our problems, our leaders are being brought to court for corruption. And those are the leaders we've elected. And it's not just in one country or another. It's relative. It's not wholly ubiquitous, thank God. But where are our leaders to really lead us into a world of integrity with the universe that we inhabit? There's so much potential. There's so much. We have enough money. We have enough capability to meet the needs of every living being. We can change things, but the motivation and the wisdom and the integrity to bring coherence out of chaos.
Yeah, it's quite extraordinary. But for the balance of the time we have, let's go back to the cosmos. Let's go from the crisis to the opportunity. And Kim Kerrigan was asking, I think, a good question in the middle of your remarks about the relationship between dark matter and light.
Okay, so what happened was we had these huge galaxies and we started to measure the motion of them. And we found that relative to the light that we could see and the gravity associated with the structure we could see, the outer edges of the galaxy were moving faster than the middle. And that's not how it should work if the matter and the gravity are working how we think gravity works. So what we understood is there is some kind of substance, some mass that's causing the outer spiral arms of the galaxy to move at the speed they are moving. And when we're looking at these clusters of galaxies colliding, there are effects that aren't strictly in the visible light. There's some other mass that we have not yet figured out what it's made of. There are all these theories, axions that came from the detergent. There are WIMPs, weakly interacting massive particles. We can't see it, but we can see the effects of it. So we know there's this thing. One of the really famous women scientists, women astrophysicists, her name is just escaping my mind. One of the telescopes is named after her, Vera Rubin. Vera Rubin was one of the first people to realize that there is this other energy, there's this other mass that's affecting the movement of structures in the universe, and we don't know what it is. We can sort of measure how much it has to be, but we haven't been able with our, it's like, Jim, reach your hand up and catch that thought you just had. Right, we can't, right.
Missed it.
Right, we can see the electromagnetic activity in the brain. We can see all that beautiful hair. We can see the head moving, but we can't catch the thought. It's invisible to our science so far. The dark matter, it's invisible to our science so far, but we can tell something's happening because there's all this funny stuff happening in the brain and it's speaking. So it seems to be conscious.
Amazing, amazing.
And there's also, so that's dark matter and dark energy. What we found is that, so the universe is expanding and we figured from gravity, it's going to get so big and then it won't have the energy to keep expanding and it'll collapse in on itself. That was the thought maybe. But what we found, and this was my friend from Australia, one group in Australia, one group in Berkeley, they got the Nobel Prize a couple of years ago for this. They found that measuring the supernova in distant galaxies, they found that the universe is not contracting, that it's or slowing down at all. It's going faster and faster and faster and faster. Wow. So there is something making it expand faster. The energy that's influencing our universe, 75% of that is that energy that's causing the expansion. We call it dark energy. Or you could go over to India and you could call it the breath of cosmos. God breathed out and eventually it will get quiet. But there's this energy, it's moving faster and faster and faster. And as I think it was either Stan or George was saying, eventually it will expand and the light will dissolve into the various and sundry black holes, and it will become the darkness again. But that's in billions and billions of years while all these processes go on. So that's dark energy and dark matter. And we don't know what dark matter is. It's a great field for scientists who want to go into having a long time to figure out something to do.
Yeah, something that's invisible and you can just track its effects leaves you with a yearning for what the causative triggering is for all that.
And some people say, okay, there's no such thing as dark matter. It's just your imagination. But they go on with the dialogue.
Right. Let me ask you to talk about the solar flares in relationship to human affairs, because as you know, beginning with a Russian scientist back in the early part of the 20th century, he noted that there was a relationship between the 11-year solar cycle and both human creativity, human violence, human interactivity would rise with the solar flares and then fall. So the fact that we are moving into the height of the solar flares between now and 2025 means, according to the evidence, and this is what I'd like you to comment on, is that we're in for an increasingly volatile, dynamic period of human affairs, both in terms of destructiveness, war, chaos, and so forth, but also in terms of human creativity and expressions of genius. What's your understanding of that?
Well, so our life source is the sun. Go outside or don't go outside, but you can feel it's just the life force of our solar system. And when there's more energy, more fire, more dynamic energy pouring on the Earth from these flares, pouring on the magnetic field of the Earth and the solar system from its increased activity, it's just like at the full moon time. So the moon, it has no light of its own. According to what we understand, it's essentially a relatively dead body. It doesn't have its own dynamic activity. It reflects the light of the sun. So at the full moon, there's more sunlight that is reaching us. It's not the moonlight per se, it's more sunlight is impacting the Earth. We've found in psychology, there's more problems, there's more craziness, there's more accidents, there's more crime, blah, 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 blah. Everyone, we know we meditate at the full moon time. There's full moon meditations everywhere. There's more energy, there's creativity. I was awake all night. It was an amazing full moon. I had so much creative energy. There's more energy from our life source. So at the peak sunspot times, just like at its minimum in the quiescent times, those effects are affecting our Earth. When you put more energy into the system, whatever's there is stimulated. When you put less energy, it's more quiescent. So it's just what the thing is. If you put a water and fire and energy into a certain kind of seed, you're going to get that kind of flower. You water it more, you'll get more, it'll have more growth. So it's the same thing. If it's depending on what we are is what gets stimulated, but there's more energy from our life source, which is the sun.
Yeah, the sun is the wellspring of it all. And it's worth just noting, everyone, that Chartres coming up, our pilgrimage to Chartres, July 2nd to 8th, is under the aegis of the sun. And that's, as Pythagoras noted, is out of the sun comes the music of the spheres. And it'd be great, Kala, while we're in Chartres, for you to do a little lecture on the sun.
I'm actually talking to Banafshe in a week or two about a vision that I have, that I want to do sort of a movement thing where we will become the sun with the solar flares and really experience it with some of those incredible images and the transformations that we ourselves go through with that. So we'll see what happens with that.
That's a beautiful idea. I love it. And so everybody, you sign up for Chartres, everybody, all of those who can on ubiquityuniversity.org. You'll see, just go to our in-person courses and you'll see the listing for our Chartres pilgrimage. And it's under the aegis of the sun. And the philosopher that guides that liberal art of musica is Pythagoras. And I'm going to be doing my little morning nuggets on Pythagoras, and Kala and Banafshe and others will be celebrating the sun while we're there for that period of time. It's going to be a beautiful experience.
So also we know, and I know music is part of this. So the sun, every single star has its own bell sound, its own music. Every star has its own music. Our sun has its own resonance, its own vibration as the plasma moves around it. So it fills our solar system and the universe, all the stars, with music.
Well, that's what Pythagoras said. Remember that the whole universe is one big song, one big poem. So we'll listen, Kala, thank you so much, and would love to have you back in a month or two to give us more updates. And at some point, I would love to have you just speak to our community about the relationship between these scientific discoveries and ancient mystical knowing. Because it's really nothing new. The mystics have known what you're talking about for like forever, but the physicists who think they have to be atheistic and scientific reductionists and, don't believe in God or the mystery are laboriously uncovering what the mystics have known for thousands and thousands of years. And I would love to have you back to talk to us about that relationship between ancient knowing and scientific advancement.
I would love to, and I have to say one statement in defense of the scientists.
Sure.
Atheism. So first, I'll just say one of my favorite people in the world was Steven Weinberg. He wrote the book, The First 3 Minutes. He was amazing, talking about the multiverse and infinite universes and all that. He was the head of the Atheist Society with all these scientists. And what he said was, look, it's not that we're really atheists. We're just looking for the God that made us rather than all the ones that we made.
Good one. Good one.
So, I always remember that because, and it's something, too much to go into now, but so much of our world conflict is because of what we call our religions, and it's our hypocrisy. It's our hypocrisy around not really following them that causes the problems. But every one of them says we're supposed to, Buddhism, go beyond name and form. In the Judaic, find the God that you can't see. Rely on your heart, not on what somebody tells you or writes or what comes from anywhere outside of yourself. There's some link inside of you to the great divine reality. It's not what somebody wrote in a book. Even the books, and this is the last thing I'll say, even the books in Jeremiah, in the Old Testament, and I love this, whoever wrote the thing in the Torah, whatever, says, I'm sick and tired of all these old guys. They're not doing what I told them to. They do exactly the opposite what I told them to. From now on, I'm only communicating from person to person directly through you. This isn't just in the New Testament, it's in the Old Testament. And whoever wrote that. So that idea of looking to see, of not being afraid of finding the edge of the universe, because we're here, we're alive. What made us? Something there that created us is beyond our reflection in our ego of it.
Yes.
So that for us, and that wonder in Zen, that thing of that, the voice of silence, that breath of wow, of that amazing, where that you really get it. And it's that moment where you really get it, where you are it, that all the traditions tell us to seek.
Beautiful.
Because we are it.
Yeah.
And it's
We are
not
what we seek.
right. It's not theist or atheist or blah, blah. It's nothing because it's beyond words. It
Yeah.
just, wow.
Yeah. Kala Perkins, everyone. Cosmologist extraordinaire. Kala, thank you so much. This has been beautiful, inspiring, and I hope you can join the after chat along with anybody else. You'll see the link in the chat box. Stan will put it in a moment, and that'll bring us to a close for today. Just as a reminder, this weekend on Sunday, Europe goes into daylight savings time. So for those of you listening in Europe, the UK, and other places that are having this dreadful experience of daylight savings time, we all hope that this is the last year. Starting Sunday, the clocks will be rebalanced and that you'll be 9 hours ahead rather than 8 hours ahead of California time. So thank you, everyone. Have a wonderful weekend, and we'll see you again on Monday. Bye for now. And Kala, thank you.
It'll be wonderful to come back and we'll figure out where we go.
Yeah. All right. Be well. Bye, everyone.